by some inode in the image that you tell it to. iCat will crash trying to pull out the data. You can see here that we're going to have a bad dereference because what we do is we check that fs data run is real in that while loop at the top, but inside the while loop it may become not real. If the next pointer inside it points to nowhere, we later dereference it anyway. So again, relatively simple bug, simply fixed, and having source code makes it a no-brainer. And again, NTFS yet again. It keeps popping up. FLS, the program, what does FLS do? Lists the file and directory names in a given file system image, including the deleted files. A handy tool. Are we? Yes. So, I didn't, yes, this one is a two-part one, so there's no highlighting. This is just the code that sets up the problem. So, we're copying data in fsdata put stir ntfs.c. The read buffer is attr plus an arbitrary 16-bit offset, and the read length is an arbitrary 32-bit length. So it's possible to read 32 bits worth of stuff out of 16 bits worth of stuff, which is obviously not going to work if the number is too big. And you can see here, this you may not know because you may not be familiar with the code of sleuthkit, but all these functions, we're going to see them a lot, like getU48, getU16, getU32. They will pull in the next number out of the file system image that you reference in the endianness that you tell it to. So this is user-controlled data. So a lot of file systems have structures like, here, there's about to come a file name, and it's 10 bytes long, and then there's some stuff. So, and then these tools often either do because they have to, or do because they couldn't think of anything else to do. They often believe those numbers. Like, oh, I've been told to read 4 billion bytes. Okay. And then they do. So one of our main points of this presentation is that people writing this kind of software need to be super paranoid. And the entire file system is attacker data. And it's super complex. And it's full of stuff that's going to contain stuff that will affect the program flow or the data that's retrieved. So here we take, as said, user data and treat it as a too big of an offset to a too small buffer. Now I'm going to NTFS, FLS. NTFS is the cause of so many problems in these tools because it's extremely complicated. Even more so than the Unix file systems, which are also amusingly complicated. Because we have a time issue, how are we doing on time? We have a lot of bugs to go through that are along these lines.
We should probably finish all the bugs in 10 minutes.
We should probably finish.
The ones that are interesting.
Yeah. Okay, so I'm going to start zooming through these a little quicker. But again, all the details are there in the paper. So let's move on to, Ncase. Another, we believe it's the leading proprietary closed source forensic toolkit. Unlike Unix, it's very Windowsy. It's a GUI. It integrates all the features that you would want into that one GUI, and you are to use it pretty much that way. It does include for programmability its own built-in programming language called NScript, which is vaguely C++y, vaguely Java. Let's say it's an object-oriented programming language from the Algol family. It's its own little thing, and you can take a class and learn it. And so where the functionality between the sleuthkit and Ncase is the same or similar, we found the same or similar types of bugs. And then Ncase goes further than sleuthkit. As we'll see, it has features for viewing the stuff that you find in the evidence image. So where it has more features, it also has more bugs, as you would expect. So it's very difficult to test and deal with. It's closed source, but that's normal. But beyond that, they've encrypted the binary with nice bonus features for you. It does try to do a little bit of anti-debugging. So like if you try to launch it from WinDebug, or probably some other debugger, it can tell and it gets angry. And you can't do the simple thing of setting am I being debugged in the PEB to 0. It doesn't believe you. So it's got something else that it's doing, but it doesn't really matter that it's doing this because all we do is just attach WinDebug after in case is fully started up. And then we can just debug it normally. And then it also has a little copy protection dongle. And so when Tim was going to do some testing on it, we would work around that problem just using FedEx. But it was still a pain in the butt. And we had the problem where we could not patch away the first hits from fuzzing. In theory, we could have done a binary patch, but we didn't.
That might be illegal.
Yeah, that might count as reverse engineering or copyright infringement. I don't even know. So being nice people, we didn't do that. But similarly, crashing, incorrect parsing of data structures, and it acts a little weird. SleuthKit's a little more predictable, but Encase has a mind of its own sometimes. But here we go. Disk image with a corrupted MBR partition table can't be acquired at all. Encase just hates it. So this one's there's a couple facets to this one. So we took a disk image and mangled its MBR partition table, and we tried it in two ways. It's a Linux file system, or Linux volume of file systems. And so we thought we would, and Encase has this thing called Linen, which allows you it runs a little server on a Linux machine. In case the target of your investigation is a Linux machine, you put this Linen thing on it, and it will feed over the network the disk image to a Encase running on Windows. It's kind of, DD and Netcat, kind of just what you'd think. And if you corrupt the disk image before feeding it to Linen, Encase won't handle it very well at all. It will crash in a way that you can get out of, or not crash, I should say.
Directly on the file system you're imaging?
This is booting off the boot disk.
Yeah, you don't have to. Encase will hang when you feed it that funny image through Linen, but you can quit out of that acquisition, and you're not totally lost. But you never can acquire it. But if you
If you just these things, just do an acquisition and check them with the wrong loss, and
I'm sorry, start
not do any analysis.
You can't acquire.
You can't
get
acquire.
the drive at all.
We didn't get to analysis yet. It can't handle this partition table at all, even in acquisition.
So you can't acquire the physical disk.
Why not?
Because for some reason it reads the MBR.
And it hangs.
So it's doing proper.
I didn't write it, sir.
So you can't put dongle on that for a download just to dump the disk.
No, it doesn't take. It's not like DD. It's much more complicated. I guess maybe in somewhere it decides how many partitions there are. Even if you tell it I want to grab just the physical, it makes the decision. Yes, there's this many partitions in the MBR, so it flips out at that point. So you can't use Linen at all. You'd have to use DD, which DD does work.
Yeah. So, but if you corrupt the disk image after Linen has started feeding it to Encase will hang in a way that you can't recover from. Just kind of Now we didn't do a lot of looking into Linen itself because we just noted this funny issue and just sort of went on. But it might be something worth looking into, testing Linen itself. So here's the partition table in question, and it has a bunch of partitions, and I've elided some. But the one in red is the funny one. Its start and end is way past the end of the disk, but it's the same size as all the others, as you can see. I think they're all 43 sectors long.
And Linux will boot with this as long as it's within one of the non-corrupted partitions.
Right.
So you can't have a running Linux machine that then Linen won't acquire at all. For the obvious question.
Here's more detail on that particular messed up partition table entry. Here's another one. This is NTFS again. So NTFS, in the MFT, the master file table, there's a bunch of there's an arbitrary number of arbitrary sized records describing each file. But one such record is called the file record. And it's expected that 61 is normally a 0. But our fuzzer just put 61 there by chance, and we happen to run into trouble here. So we'll see in the next slide that that number is used as an offset to an allocated memory region. That it makes it 6130 makes that memory region, makes a memory reference go out of bounds to that region. I apologize for the tiny, tiny, tiny words here. But again, the paper, you can look at it, put it right up to your face. But you'll see that, I believe it's EDI. Yeah, I have the laser pointer and everything. Only I don't see the... Yeah, EDI, right here. It starts from a base of 02CE0000, which is the address of the allocated blob. And then it believes our number. It's got 6132 there. And then you get a out-of-bounds dereference, and it dies. So one little byte makes it so that it can't, you can't acquire that file system. Out-of-bounds read. Similarly, okay, is this similar? I think this one might be different. Okay, yes, this one is a little different. This is post-acquisition. We made a fuzzed Microsoft Exchange email database, and EnCase has features to read through those, which is cool. And when you acquire it, you can say, oh, hey, please do look for Exchange mail databases and look for other types of stuff. And we, just as a general matter, just to find as much trouble as we could, we always made a habit out of just checking all the possible search, hash, and signature analysis options, even though we didn't always have the relevant type of file. So we could have done more work to isolate exactly which checkbox triggers the feature that has this bug. But that's not really super interesting to us right now. So again, we have a read access value, a read access violation. This time it's EAX instead of EDI. But the funny thing about this bug is we ran this one a bunch of times, and the particular value in EAX changes. You can do the exact same GUI movements and give it the exact same input files, and it'll crash in a slightly different, it's the same EIP every time, and it's the same problem of a out-of-bounds dereference, but the exact place it's trying to go is a little different each time. Just seems kind of weird. Don't know why. Let's see. How are we doing on time?
You got like 2 minutes.
2 minutes. I want to skip ahead to, yeah, that one's not too awesome. This one is a good one, and I'll spend my last 2 minutes on this. So EnCase and Linux, again, what do you know? They interpret an extremely complicated data structure in different ways, because there's multiple interpretations of it. NTFS in particular, if you don't already know, it's really redundant and really flexible and pretty strange. So it makes sense to me there's lots of trouble here with NTFS. So we manually created a directory loop in an NTFS file system image, and then gave it to Linux using the 3G driver, and we gave it to EnCase, and they both handled the problem differently. Linux sees a directory loop, boop-a-doop, just like you would think. A child is its own parent. In EnCase, there's no loop, and the file that supposedly is itself, or its parent, it's there as a file, but other files in the same directory, EnCase just can't see them. So there's a chance there for an attacker who likes to use Linux and the 3G driver to hide his evil evidence or whatever, to make EnCase miss it. And it will be, he could extract it in his own way, but EnCase